All right, folks, let's start. Hello, everyone. This is Dr. Yuzo. This is ECE 360 control system class, and this is our 14th lecture. And can you guys hear me well? And all right, thank you, Vincent. Thank you, Alex. All right, and also being able to watch my see my screen, right? Shared notes under the doc cam. You guys see that? All right. Thank you too. Let's go ahead. So this is the last example for the unity feedback system, looking for the system type and steady state error for different inputs. Once again, be very careful, okay? What we have learned in this module so far is all about unity feedback, okay? Unity feedback. If you learn how to deal with non-unity feedback system, okay? And it's the second half of today's lecture, okay? And if you have reviewed the previous examples and the lecture, you should know the solution of this problem should follow a rough idea or say the procedure like this, right? The first step, you need to find out the forward transfer function. Okay? Forward transfer function. This is always the thing we are looking for at the first place. If it is nice, the forward transfer function is given directly like this example 3. If not, you need to somehow find it from maybe the given block diagram. Okay. Therefore, you need to understand what does it mean by forward transfer function in the given block diagram, right? Anyways, this problem is giving you the forward transfer function g for s because we are looking for the system type. The system type is determined by the order of the s term in the denominator of the forward transfer function. So we need to organize the denominator of the g of s to become something like this, right? This is the given denominator. From here, we cannot directly tell the system type. So what can we do? Basically, you pull out this s squared term and leave the rest of the polynomial inside of the parentheses, right? Does this make sense? To put this out. Just this is pretty much it's not difficult, but just reminding you that we are looking for the s term, and the order of it is the system type. So if you're not seeing the s term like this polynomial, you need to somehow find s term. Of course, maybe that s term is 0, 1, or any other value. But to here, you obviously can pull out an s squared term out of the polynomial. So remember to do that. Now it's safely for us to tell the system type is nothing but 2. Type 2 system. This type 2 system. This is the answer for the first question here. And then we go ahead to find the steady state error for different inputs. First of all, the first input is a what? By checking our Laplace transform, you should be able to tell this is a step. First input is step, and the corresponding S domain function is 80 over S. Second here, this guy is a ramp, right? And the corresponding S domain function is 80 over S squared, right? Third one is what? Is a parabolic, right? 80 over S cubed, right? Any questions so far? Good. Here we go. Obviously, Alex, both Alexes find a problem. Don't make this mistake. It's something easy. However, you can lose point for it. Okay. It's not 80. Okay, it's not 80. It's 160. Okay, 160 over S cubed. Once again, because of the Laplace transform, one of our handouts given previously. After having these, actually, you need to be clear. Look for the steady state error as the last step. You need to be clear. A type 2 system lead to what? Lead to 0 steady state error for both step and ramp. And this is something we learned from last lecture. Okay. I summarize the 3 different types, at least 3 types of system, and the corresponding resulted steady state error for different input. Okay. So what's the conclusion? Very easy, right? Once again, 0 steady state error for step and ramp. You don't need to do anything, just have that conclusion listed here. Because we kind of are defining the step, ramp, and the parabolic in order as R1 through R3. So correspondingly, the E1 through E3 representing the step input steady state error, ramp, and the parabolic input steady state error, okay, respectively. So they're in order. Just need to really find the really conduct the limitation to find the steady state error for the parabolic input. This is also one of the conclusions in the summary. Okay. Type 2 system has a finite constant steady state error for parabolic input. Here we need to apply the formula. So first of all is a limitation, like s approaching to 0. And then the formula we have is s times g. Over 1 plus g. Right? Good. Now how to make it right? R, right? Exactly. That's 2 set. It's R3. Right. Good. Good. Therefore, what do we have? Because here is s times 180 divided by 1. This guy, then equals to 160 over s squared, right? And then what you want to do is times this s squared into the denominator. And then it basically equals to, now you can substitute s equals 0 into the division here. So 60 times 3 parentheses. Denominator is square 23s plus 102. Right? And of course, s equals to 0. And further, it equals to 160 over 0 plus 60 times 3, 4, 8. And denominator is 0 plus 0 plus 102, right? Final answer, steady state error for parabolic input for this particular system is 2.83. Finite constant makes sense. Any questions regarding this last example for unity feedback system? Any questions? All right, if this is fine, then, well, just do a little bit of exercise. And obviously, if you really feel this is easy, make sure you got 15 out of 15 in the exam. Right? That's what really matters. Now let's talk about how to deal with the non-unity feedback system. Okay. So basically, steady state error for non-unity feedback system. How to find the non-unity feedback system error. It's actually not difficult. It's not difficult. Idea is very simple. Idea is as simple as just what? Find the equivalent unity feedback system. Just find the equivalent unity feedback system, and then whatever we have been doing for unity feedback system gonna be applied to this non-unity feedback system. Just to find the equivalent unity feedback system. Let's see how to do that. Okay, assuming there's a non-unity feedback system, non-unity feedback. Obviously, the generic block diagram, or say the system, is like this, right? Generic non-unity feedback system. Okay. Saying h is not equal to 1. Right. Then how to find the equivalent unity feedback system for this guy? We need to do some what? A block diagram algorithm, or say algebra, right? Which was the module 2, I think it's module 2, knowledge. Anyone has any idea? Any guessing? Based on the knowledge back there, we can find the equivalent unity feedback system for this block diagram. Anyone, any idea? Any try you want to do? How to somehow make this? Yeah, go ahead.
Would you just do the closed loop transfer function of that?
Find the closer transfer function. What does that mean by closer?
Closed loop.
Closed loop. And if you find a closed loop, because the thing is, if you find the closed loop transfer function, and then what is the result is this, right? This is, and then here, this guy is closed loop transfer function. Yes, these two are equivalent, no problem. However, this system what has no feedback. Right? If you do closed loop transfer function, yes, you end up with a block which is representing the total transfer function without any feedback. What we are looking for is the unity feedback. So any other idea?
Well, we should be able to use our principles for shifting the H.
Shifting the H.
So that way we can try to get that to be unity, right?
I mean, if following John's idea, we shift H out of the feedback, right? We shift it to here or here, and then the feedback here, yes, is unity. However, because what we are looking for is like this, right? Is something. This. Right? I mean, if you shift your H out, and then where you can shift it to, right? You shift it to here, you're gonna have something here. You shift it here, you got something here, and then you got something here. It's not like this. It won't be like this. Does it make sense? It won't be like that. How you make the unity feedback happen?
So if we use the original function for unity feedback, all it really has is S multiplied by R over 1 divided by or plus G. Does that hold, like, is that universal? No, because the one is
not. Absolutely not. Otherwise, we don't need to worry about the non-unity or unity, right? That's absolutely not unity. Before we make this unity feedback system happen, before this happens, we cannot apply that formula. That's the point. That's exactly the point.
We move H to a summing junction.
Move the H to here, you said?
Yeah, and then multiply it by the R inputs.
No. Then the result system is like this, right? You have something here. You cannot combine this guy with the inputs input. The reason that input is a signal, this is a transfer function. You combine them. No, you can't do that. Because when we study the system, you still need to include this part. Right? Input is input, out of our control. We cannot easily consider we can combine this guy, which is inside of the system, and be something we cannot control. No, they cannot be combined.
So can't we just derive another function then that incorporates the feedback as non-unity?
I know what you say. That actually works. Yeah, that's true. However, here the idea is not the idea. It's not that idea. I know what you say. But this is not that idea. We find something equivalent. That way, I agree. Actually, it should work. It should work. So keep thinking here. Focus on here. How you make this to become a unity feedback system? By applying the block algorithm, the algebra. No, Alex is, here is saying find the open loop transfer function, which is GH, as the new forward transfer function GH. No, that makes no sense. I mean, you cannot say this guy equivalent to, say, are these two equivalent? No.
Could we split H into two parallel branches?
Which, who, and whom then?
It would be H, and then the other parallel branch would just be 1.
If you split that, it won't be equivalent.
All right, it'd be 1 plus H. Yeah.
However, Sawyer has give us the correct solution. His idea is right. Okay, that's the solution. That his result is wrong. Okay, take a look. How to make the unity feedback happen, just like Sawyer just proposed. Okay, so Sawyer is actually 50%, well, actually 70% right. You develop a new unity feedback like this in black. Of course, if now this is H, if this is H, of course, these two are not equivalent, as we just said. However, what you can do, very easy. You give a negative feedback, okay. I give parallel, give you what? -1, how about that? But you gave 2 now. And if you combine this 2 parallel, what do you got? 0, nothing. And therefore, equivalent to the original system, right? And now this is not a unity feedback system. Then how to organize it further? You keep G, okay, keep it. And then how to see the unity feedbacks?
Well, we should be able to add H and -1 in parallel.
Exactly. That's
incorporate
exactly what we should do.
Feed forward, right? Using the principle or no?
Exactly. Now you see the unity feedback here, right? Of course, now it's still not equivalent to something like this. So what do? You combine. Now you can combine this two. Combine this two, and then you got what? The nature is what? A brand new forward transfer function here. Does it make sense? You keep this guy. Combine this two. Combine this two. What is it? Anyone remember? This two combined is what? Is a ratio, right? And the numerator of the ratio is what? Yeah, I saw Sawyer saying, "Oh yeah, right." He basically can claim 70% of the credit with the numerator here. Is well, Kevin's answer is close, but not exactly right. Numerator, first of all, is G itself, right? Denominator is what? Is 1 plus G times H minus 1, right? This is the algorithm for a feedback system. Of course, it also equals to G over 1 plus GH minus G, right? And then the same thing. So this is the resulted equivalent unity feedback system. Unity feedback system. And of course, be very careful which is which. So first of all, G here is what? Is non-unity feedback. Non-unity feedback system forward transfer function. Right? And H here is what? Is the non-unity feedback system feedback function, right? Then obviously, what is the new forward transfer function? In other words, who is the non-unity, who is the equivalent unity feedback system forward transfer function? Who is it? Just this guy, g over 1 plus gh minus g. Right? It's a new equivalent unity feedback system forward transfer function. Why we are looking for forward transfer function? Because now it is unity feedback system. We're applying whatever we have learned from the unity feedback system into this new system. Okay? So we need forward transfer function. That's still the forward transfer function, not any other transfer function. That's still the forward transfer function. Now apply the formula. Fairly easy, right? Does everything make sense? Any questions? All right, if this is fine, then go ahead. All right, keep this formula here. Keep this formula here, and then we apply which to conduct the example 4 of this module, which is a non-unity feedback system. Is given as this block diagram. Yeah, my handwriting is a little bit hard, I think, to differentiate the S and the 5, but I'm writing 5 in this way. I think it's should be clear now. I'll give you guys some time actually do this yourself. Just find a steady state error for input of unit step. All right, go ahead. You should know everything you need. And this formula is here, and just go ahead. Give you guys 10 minutes. Try it over for 10 minutes. Go ahead. No, it's not zero. Not zero. Anyone got any result? All right, keep trying. Any other answer? Don't we need input values? Come on, Sawyer, read the problem carefully. Input of unit step. That's all you need. No. Neither Noah's answer nor Kevin's answer, unfortunately, nor Jeff's answer is right. No correct answer yet.
Is it a zero system type, or am I not on the right track?
Yeah, that's a good question. First of all, is what type? What do you guys got? Type, system type. Yes, system type is 0. Who is not right answer either, unfortunately.
I got 0.0275.
I'm afraid no.
Oh, wait, 1 divided by 101.
Any
Point
other result? Anyone?
one.
What do you got again, John?
0.01 or 0.099.
No, still not right. I think I'm not giving the wrong problem, but no, I don't think so. Any other answers? Well, no, 0.2 is not right either. Here we go, finally. 7 and 2, these two guys got the jackpot. Yes, 94. Okay, 94 is the correct answer. Okay, let's go over this entire thing together. Kevin and 2 got this. They got this. All right, let's see. But first of all, the input is unit step. Unit step, you need to understand it means the constant of 1 divided by s. This is a unit step. Unit step. And then what you need to do is obviously the forward transfer function. Of course, in your mind, you need to be very clear. We're looking for what? The new non-unity, the new equivalent unity feedback system forward transfer function. Okay, forward transfer function. Feel free to call it G prime. Feel free to call it G prime. of s. And equals to what? Well, we have formula here. We have formula equals the original g over 1 plus g h minus g, right? So numerator is original g. Who is original g? Is this guy, right? Just the 100 over s times s plus 100, right? This is the original g. Denominator is 1 plus this g times h. What is the result? It's just equals to 100 s 100 s plus 5, right? This is g times h. Okay? And the minus g. Well, minus g is minus 100 s plus 100. Okay? First of all, remember, don't freak out. Okay, it is what it is. You're not shaky. Okay. Further, you need to organize this. How to organize this? It's not something difficult. You put this denominator to be equals to what? You give a common denominator, which is this guy, right? And then the numerator is repeating this guy, which is from 1 plus 100 minus 100 times what? S plus 5. Right? This is how you got the denominator. How you got the denominator. Right? Into this black and the numerator here, you immediately will cancel s times s plus 100. Right? And then you flip the denominator, so s plus 5 becomes numerator, right? These are basic algebra. Right? This is a resulted new forward transfer function. Right? New forward transfer function. Now you can further to derive it, of course, here. Equals what? Equals to 100 s plus 5. Denominator is a s polynomial. Right? Denominator is a polynomial of s, obviously. And what do you see? Type what? Type 0. Type 0. You don't have s term. You don't have an s term. Does it make sense? And then what do you need to do? Steady state error, once again, we just review it. Numerator s times the input, which is 1 over s. Denominator is 1 plus this new guy. 100 parentheses sq plus 15s squared, blah, 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 blah. Right? Does it make sense? Once again, you make the denominator to because numerator is 1, constant 1. And then you basically substitute s into this right? Right? And then this equals what? 1 over 1 plus, this is what? 105 divided by negative 400. Negative 4. Right? who all of you guys who made mistakes, I will say congratulations, right? Because I believe you won't make the same mistakes in the upcoming exam. And that's exactly why we are doing this in the class. Right? Well, Alex got his mistake. How about yours? Like Sawyer, what's yours? Speak.
I didn't expand the polynomial in the denominator.
No, you should. You should. Because we're doing that, well, you can't see. You can't see.
Right.
Yep. John, what's yours?
I think it was algebra towards the end for the error.
You think, or you
Yeah, I
pinpointed?
erased everything, so I don't know for sure anymore.
You want to be sure, okay? You want to be sure before the exam. Otherwise, you're very likely to make the exactly same mistake again. Remember, human being behaves in pattern, in our own pattern. If it is right, always right, most likely. If it is wrong, always wrong, most likely. It's in pattern. And Elliot saying algebra, then you need to pinpoint which algebra you're doing wrong. Not simply algebra. Some algebra you probably just lose half point, and some algebra you're gonna lose 5 points. You need to pinpoint what kind of algebra it is. Noah, what was yours mistake? That's okay. That's okay. Take your time. Find the problem. Find the problem. And now let's do one more example. Okay. Meantime, let's do one more example. It's good that see so many of you guys are trying. Very good. Very good. Oh, so Yadav has a question saying how you got the s times 1 over s in numerator. Here, this is the formula. The formula, I mean, the formula we have been using here. Recalling the previous example, this is the formula we apply. Numerator is s times the input. Here is still as time s times input. The input we have specified here. So it's s times input. Does it make sense now? Speak out. All right, you got it then. That's good. All right. Next example. 5. And then unity feedback system even has this. And then find first the system type. Second, that is the error for inputs. Well, unit step, unit ramp, and unit parallel link. I'll give you guys another 10 minutes. Go ahead. All right, seems it's much better. Kevin has already got the correct answer for all of the questions, but give you rest of you guys some more time to keep trying, and I will present the solution here. All right. No, I got them too. So let's take a look at the solution. Basically, following the exactly same procedure here. So forward transfer function, g prime is just equals to numerator is original g itself. Right, and denominator is 1 plus g times h. So okay. Minus g. So what we need to do is once again make the denominator become a single big fraction. So denominator obviously s times s plus 2. Numerator, you need to be patient. You need to be patient and careful. Right. This is the denominator. This is the denominator. And from here, you can easily tell the here and here are canceled. So numerator is this left. Denominator is, if you extend the polynomial, then you end up with this. So calm down and go to do one more derivation here. Keep the numerator same. And then from denominator, what can you see? You can pull out one s term. Okay, you're able to pull out one s term, and instead of the parentheses, you end up with this. Okay, this is where we draw a conclusion that type 1 system so the key is what? The system type here, always remember, is from the new equivalent unity feedback system forward transfer function, G prime. We're not deriving the system type, this conclusion, from the given non-unity feedback system forward transfer function. Okay, be very careful. Be very careful. From here, we cannot tell that. Not necessarily. Okay. So I'll tell from here, the G prime. Just telling you this. And if you got this G prime correctly, then the next, just so again, who are those three input? They're very straightforward. And what is unit step, unit ramp, and unit parabolic. Unit step we used in previous example. Constant of 1. Unit ramp, same meaning. Constant of 1. Right? Third one is unit parabolic, means what? 1 of s cube. 1 of s cube. That's a unit parabolic. Because of the type 1 system, what is the conclusion? Step, input, what is the steady state error? This is type 1. What is it? Good. Okay, 2 is right. 0. Type 1, temp input, what is the status error? What is it? Anyone?
Constant.
Constant. Very good. I like constant. Okay. Which means what? It means we need to start to do the algebra, like it or not. Right? Doesn't make sense. Numerator s times input, denominator 1 plus g prime. Right? But we don't need to do it. We can finish the third one, which is easy. What? Infinity. Right? Infinity. It's a type 1 system. The status error is infinity for parabolic input. Okay, this is part of the summary we had previously. If these are fine, then we can go ahead to find this. So this is approaching to 0, and then you want to divide. You want to times the s into the denominator. Right? Numerator becomes 1. Denominator becomes s plus s times this guy. And s plus 10, 11s plus 102. What do you happen? What do you see is this s and this s canceled, and then further equals to what? Numerator 1, denominator 0 plus what? 10 times 10, right? Denominator is 102. Eventually equals to 1.02. Take a look to see any questions. Yep, here I'm pretty much also show you to conduct the algebra. What's the most effective way to conduct the algebra here? Especially here. Don't freak out. You make them together to become one single fraction. Uniform the denominator. Any questions? All right, if this is fine, then I think the rest of the time, just for you to do anything midterm 2 then. Any questions regarding the midterm 2? Once again, I'm presenting the review I provided in last lecture. So any questions, any concerns? I posted a new announcement this morning saying all of the handouts, okay, all of the handouts ever been given are allowed to be used during the exam. You just have them ready by side and then use them. All of the handouts are allowed. For previous module 1, 2, 3, okay, use them. Use them if you think they're helpful. In addition to one cheat sheet.
I have my cheat sheet stapled to my handouts. My old sheet for exam 1.
And
Um, Can I just leave that all together, or do I need to remove that one?
Your cheat sheets,
From exam 1.
your new cheat sheet, right? Are you developing new cheat sheets stapled with the old handout?
I'm saying, can I leave the cheat sheet from exam 1 and add the new cheat sheet for exam 2?
Oh, you're using that cheat sheet.
Well, I just don't want to have to take it out, but I mean, I can if you don't want us to have the old cheat sheet.
That's fine. That's fine. I don't see how that can help, but yeah, you can use that. You can use that. But one thing I need to remind you guys to don't put too much things by side. I'm not saying don't cheat. I'm not saying, what I'm saying is for your own good. You have too much material by side, it might mess up your mind. Okay. Make them concise, easier to access, easier for you to find whatever you need to find. If you put a book by size, that's a very bad idea, don't you think? How long are you going to spend looking for the book by flipping the pages, right? So you need to be careful on this. Not the more the better. No, not really. Okay. Sure. Are there any questions regarding this exam?
I have a question.
Yeah, go ahead.
On like problem 3 on the exam.
Which is this guy?
Yeah.
Mm-hmm.
That one right there.
Yep. What's the question?
Can you do one example?
One example. I think the best example is this handout. I think this is there's no better example than this handout. 1 second.
I kind of have the same question as well. I mean, maybe regarding that question in specific.
Okay, here. Then I will answer it to both of you. So I'm gonna give you something like this, right? The blue curve is whatever I'm gonna give you, and I'm asking you what to find, because there's labeling, right? Labeling along the x-axis is time, y-axis is the output reading, right? But by giving you this blue curve, I'm asking you to find the estimate, for example, the peak time. What is the peak time? You need to find this point is the peak time, right? So you basically go down to here and read this time value. Does it make sense? Find the settling time is a little bit tricky because you cannot easily locate the 2% of the final value, steady state value. However, you just somehow try to estimate it. You basically estimate along the approaching to the steady state value, somewhere you think is come into the 2% range, and then corresponding time here.
Because I mean, that would be, I'm assuming from person to person, that could be
a little bit off. I have to admit it.
Yeah.
The trouble I'm having is, if this is a face-to-face exam, I'm gonna give you that paper, right? If on that paper you can label, you can draw, you can present your understanding on that paper. However, this is online exam. I'm not able to do that, right? I'm not gonna mail you the paper, right? And guaranteeing you are receiving that paper no later and no earlier than the exam time. No way to make that happen. So I understand. I do understand. That's going to be off a little bit. That's true. And also, what's the steady state value? You need to be able to rate, right? But this handout, there's nothing better than this handout. Of course, you also need to understand what? You need to understand for the second order system, right? What is the formulas you're using? to relate TPTS and overshoot, relate these specifications to what? Zeta and omega n, right? You have formula. Understand what I'm talking about? You need to have that relations, okay, that formulas on your cheat sheet, so that based on TPTS, you are able to find zeta and omega n. Or maybe just a real part and the imaginary part of the poles. Because the poles, real part and imaginary part also in terms of omega n and the zeta. And understand what I'm saying? Or more?
Yeah.
Okay. You need to have that formula ready. In other words, this problem is like what? I'm not giving you, because problem 2, say problem 2 is what is the opposite, right? Problem 2 is given the transfer function. I'm looking for T, TS, TR, TP, because from the transfer function you can find omega and the zeta, right? And from omega and zeta you can calculate these 3 things based on that formula, based on those formulas. Problem 3 is the other way around. You read the TP, TR, and TS from the given graph. And then you might want to go back to zeta and omega n, or even the poles. Does it make sense? So problem 2 and 3 are procedure-wise opposite. Make sense? Is that clear too?
Yeah.
All right. Good. Any other questions? Any other concerns? Yeah, I agree. I agree with 2 actually, because we have examples for problem 1, 2, and the 4 and the 5. Yes. Problem 3. Problem 3, we didn't have example, but that's nothing but definition. Nothing but definition. And yes, 5 points of extra point to be claimed. See how much you can have. Five problems, 75 points, 75 total points. And if you get them all and also some extra point, you end up with like 78, 79 out of 75. Well, so be it. Any other questions? Anything I can help? All right. So thank you for attending today's lecture, and good luck with the midterm 2. Okay. All right. Talk to you guys later. Oh yeah. I'm sorry. Well, one thing. Just the one thing. I think. Make sure you have a good network connection. Okay. Because after the first midterm 1 in all of my classes, I found someone's proctoring video, which is the respondents monitor videos, are not available from the lockdown browser. That is absolutely not okay. Okay. And ITS Canvas company and I are working on investigating what's the reason behind. And I hope it's not something very serious, but you got to be careful. From students, be careful about network connection and the position of your webcam. Make sure your proctoring video are available and nice, okay, so that I can see you working on the problems. Okay, this absolutely matters. It absolutely matters. All right. All right. Thank you all. And once again, good luck with the midterm. Bye
Is
now.
there any, Dr. Zoe?
Yep.
Is there any way to know, like, who, like, if you couldn't get access to
Oh.
the video, were you gonna
I
let?
have sent
know?
an email to those guys individually.
Oh, okay.
If you're not receiving any email, that means you're fine. Does it make sense?
All right.
All right. Bye now.